Hello, in this lecture we'll find out the area of a square. In the drawing we have triangle ABC. Triangle ABC is a right triangle. That is to say angle ABC equals to 90 degrees. Inside the right triangle ABC we have this square DEFG. And our mission is to find out the area of this square DEFG. In addition, we know that side AB of the right triangle ABC equals to 5 units in its length, side BC equals to 12 units in its length. Again, our mission is to find out the area of this square DEFG. So, first of all, we find out the length of the hypotenuse AC of the right triangle ABC by implementing the Pythagoras theorem on this right triangle, triangle ABC. So here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC square. And it must be equal to AB square plus BC square. Repeat again, in the right triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. So AC square, it is the square of the hypotenuse, equals to AB square. AB is 5, therefore AB square is 5 squared, that is 25. Plus BC square. BC is 12, therefore BC square is 12 squared, that is 144. So in conclusion, found out that AC square equals to 25 plus 144. 25 plus 144 is 169. So AC square equals to 169. We take out all of this equation. And finally we get that AC equals to the square root of 169, that is 13. So the length of the hypotenuse AC is 13. So I write it down in the drawing. AC equals to 13 units. We will implement in our drawing the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so here line segment AC is one side of the right triangle ABC, therefore it is absolutely a straight line. So if we focus on the lower side of the straight line AC at point D, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point D, here we have this angle that is 90 degrees plus this missing angle. In total they must be equal to 180 degrees. Therefore the missing angle here must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles the lower side of the straight line AC at point D to 180 degrees, the missing angle must be equal to 90 degrees in its size. Likewise, we focus on the lower side of the straight line AC at point E. Here the sum of the angles must be equal to 180 degrees. So which angles we have at the lower side of AC at point E? We have this angle that is 90 degrees plus the missing angle. In total they must be equal to 180 degrees according to the order mentioned. Therefore the missing angle here must be equal to 90 degrees in its size. We define the length of line segment VG as x. So what is the length of line segment GC? From drawing it is very easy to see that GC equals to BC minus BG again. BC minus BG equals to GC. So GC equals to BC, that is 12, minus GC, that is x. So in total, GC equals to 12 minus x. We define the length of one side of this square DEFG as L. Therefore, all the other three sides must be also equal to L. Why? Because in any square, all the sides are equal to each other. We focus, first of all, we define this angle, that is actually angle ACB, as alpha. And we focus on the right big triangle, triangle ABC. On the right big triangle, triangle ABC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. So the missing angle here equals to 90 degrees minus alpha. We define 90 degrees minus alpha as beta. And therefore, the missing angle here equals to beta. Here we have the equation that 90 degrees minus alpha equals to beta. We will add to this equation alpha and then we subtract beta. And we get that 90 degrees minus beta equals to alpha. In the next step, we focus on the right small triangle, triangle ADF. In the right small triangle ADF, this angle equals to beta, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha. Therefore, the missing angle equals to alpha. Likewise, we focus on the right triangle in GC. On the right triangle in GC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta. Therefore, the missing angle equals to beta. In the next step, we know that line segment BC is one side of the right triangle ABC, therefore it is absolutely a straight line. So BC is a straight line. We focus on the upper side of the straight line BC at point G. On the upper side of BC at point G, we know that the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. The sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have at the upper side of BC at point G? We have this angle that is beta. This angle that is equal to 90 degrees plus the missing angle. In total, the sum of those three angles they must be equal to 180 degrees according to the rule that I mentioned. So the missing angle here must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles on the upper side of the straight line BC at point G. So the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha. Yeah. 90 degrees minus beta equals to alpha, therefore the missing angle equals to alpha. In the right triangle FBG, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle equals to beta. So, in the drawing we have in total 4 right angles, 1, 2, 3, and the big right angle ABC, so in total we have 4 right angles. Actually, all the triangles of all the 4 right angles are correspondingly equal to each other. Each triangle has the following 3 angles, alpha, beta, and 90 degrees. Therefore, all the 4 right triangles are similar to each other according to angle similarity rule. For example, the right big triangle ABC is similar to this small right triangle FBG. So I write it down. The right big triangle ABC is similar. This is the sign of similar. So it's similar to the right big triangle FBG. According to angle similarity rule. And from the fact that the right triangle ABC is similar to the right triangle FBG, we derive that the following relationship exists between their sides. We derive that BG over FG in the small right triangle FBG is equals to BC over AC in the right triangle ABC. Repeat again. We derive that BG over FG equals to BC over AC. So BG is X over FG. FG is L. And it is equals to BC. BC is 12 over AC. AC is 13. So in conclusion found out that according to equation 1, X over L equals to 12 over 13. Here we'll multiply this equation by L, and we get that X, according to equation 1, X equals to 12L over 13. Likewise, we know that the right big triangle ABC is similar to this right triangle EGC. So write it down. The right big triangle ABC is similar to the right small triangle EGC according to angle similarity rule. And therefore, the following relationship exists between the two similar triangles. GC over GE in the right triangle EGC equals to AC over AB in the right big triangle ABC. Repeat again, from the fact that the right big triangle ABC is similar to the right triangle EGC, we got that GC over GE in the right triangle EGC equals to AC over AB in the right big triangle ABC. So GC is 12 minus x over GE. GE is L, and it is equal to AC, that is 13, over AB, that is 5. So in conclusion, found out that according to equation 2, 12 minus x over L equals to 13 over 5. Here we will cross multiply this equation 2. And we get that according to equation 2, five times 12 minus x equals to 13L. Here we'll open the brackets on this side of this equation 2, and we get that according to equation 2, 5 times 12 is 60, minus 5 times minus x is minus 5x, and it is equals to 13L. Here we add 5x to this equation 2, and we get that $60 equals to 5x plus 13L. Here we subtract 13L from this equation 2, and finally we get that 60 minus 13L equals to 5x. So here we will substitute x in this equation 2 by the value of x that we found in this equation 1. Okay. Repeat again, we substitute x in this equation 2 by the value of x that we found in this equation 1. We do it now, and we get that according to this equation 2, 60 minus 13L equals to 5x, and x according to equation 1 equals to 12L over 13. So in conclusion, found out that according to equation 2, 60 minus 14L equals to 5x, and x according to equation 1 is 12L over 13. So actually we found out that according to equation 2, 60 minus 14L equals to 5 times 12L is 60L. So in total this expression equals to 60L over 13. Here we multiply this equation 2 by 13. And we get that according to equation 2, '60 times 13 is 780, minus 13L times 13 is minus 169L, equals to 60L. So here we add 169L to this equation 2, and you get that according to equation 2, $780 equals to 60L plus 169L equals to 229L. So if I know that 780 equals to 229L, here we divide this equation 2 by 229, and finally we get that L equals to 780 over 229. $780 over 289, 229, again, L equals to 780 over 229. So 780 over 229 equals to 3.40611 units. So L equals to 3.40611 units. And the area of this square DEFG is equals to the length of one side squared. The length of one side of the square squared. We know that the length of one side is L, and the length of one side squared is L squared. L is 3.40611, therefore L squared is 3.40611 square. And 3.40611 square is equals to 11.6016 square meters. If we found out that the area of square DEFG is equals to 11.6016 square units. So repeat again. The area of this square DEFG is equals to 11.6016 square units. So in the next step, I will summarize the lecture. In this lecture, I found out the area of this square DEFG. In the drawing, we have a right triangle ABC. Inside this right triangle ABC, we have this square DEFG, and our mission is to find out the area of this square DEFG. In addition, we know that the length of side AB is 5, side BC equals to 12 units in its length, and this is angle ABC, that is a right angle. Again, our mission is to find out the area of this square DEFG. So first of all, we implemented the Pythagoras theorem on this right big triangle, triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC square, and AC square must be equal to AB square plus BC square. Again, according to the Pythagoras theorem, in the right triangle ABC, AC square must be equal to AB square plus BC square. So, AC square, that is the square of the hypotenuse, must be equal to AB square. AB is 5, therefore AB square is 5 square, that is 25, plus BC square. BC is 12, therefore BC square is 12 square, that is 144. So in conclusion, we found out that AC square equals to 25 plus 144, that is 169. So AC square equals to 169. We took a root of this equation and finally found out that AC equals to the square root of 169, that is 13. So the graph of the hypotenuse AC is 13. Then I presented to you the rule and implemented the rule in our drawing. The rule is that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, again, the sum of the angles on one side of a straight line is equal to 180 degrees. Line segment AC is one side of the right triangle ABC, therefore it is absolutely a straight line. So if we focus on the lower side of the straight line AC at point D, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point D? We have this angle, that is the right angle, plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees. Therefore, the missing angle must be equal to 90 degrees. Likewise, if we focus on the lower side of this straight line AC at point E, here the sum of the angles must be equal to 180 degrees. So which angles we have at the lower side of AC at point E? We have this angle, that is the right angle, plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees. Therefore, the missing angle must be equal to 90 degrees in its size. Okay. In the next step, we define the length of this line segment VG as x, and therefore BC equals to BC minus BG. Again, BC minus BG equals to GC. So GC equals to BC, that is 12, minus BG, that is x. So in total, GC equals to 12 minus x. And we define the length of one side of this square, DEFG, as L. Therefore, all the other three sides must be also equal to L in their lengths, or because in any square, all the sides are equal to each other. Okay, and then we define this angle as alpha, and focus on the right triangle, triangle ABC. On the right triangle, triangle ABC, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. So the missing angle equals to 90 degrees minus alpha. We defined 90 degrees minus alpha is beta, and therefore the missing angle equals to beta. Then we focus on the right triangle ADF. On the right triangle ADF, this angle equals to beta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle equals to alpha. Actually here, if 90 degrees minus alpha equals to beta, it means that 90 degrees minus beta equals to alpha. So the missing angle equals to alpha. Then we focus on this right triangle, triangle EGC. In the right triangle EGC, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle equals to beta. Okay. Then we focused on line segment BC. line segment BC is one side of the right triangle ABC, therefore it is absolutely a straight line. So if you focus on the upper side of the straight line BC at point G, here the sum of the angles must be equal to 180 degrees according to the order that I mentioned. So which angles we have at the upper side of BC at point G? We have this angle that is beta, plus this angle that is the right angle, plus the missing angle. In total, the sum of those three angles must be equal to 180 degrees according to the rule that the sum of the angles on the upper side of the straight line is equal to 180 degrees. So therefore the missing angle must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles on the upper side of the straight line BC at point G. So the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle equals to alpha. In the right triangle FBG, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle must be equal to beta. So in the drawing we have in total 4 right triangles. 1, 2, 3, and the right big triangle ABC. In total we have 4 right triangles. And actually all the 4 right triangles are similar to each other according to angle similarity rule. Why? Because of the fact that each right triangle in the drawing has the angles of alpha, beta, and 90 degrees. Okay, so all the 3 right triangles in each triangle are correspondingly equal to all the right triangles, all the other triangles, all the angles of the triangles of another triangle. And for that reason, those 4 right triangles are similar to each other according to angle similarity rule. Why? Because they have the same angles, alpha, beta, and 90 degrees. So for example, the right big triangle ABC is similar to this right triangle FBG. Why? Because the right big triangle ABC has the angles of alpha, beta, and 90 degrees, and this right triangle FBG also has the same angles of alpha, beta, and 90 degrees. So here we have the right big triangle ABC is similar to the right triangle FBG. Okay, and from the fact that those 2 right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that BG over FG in the right triangle FBG equals to BC over AC in the right triangle ABC. Repeat again, we derive that BG over FG is equals to BC over AC in the right triangle ABC. BG is X, FG is L, BC is 12, and AC is 13. In conclusion, found out that according to equation 1, X over L equals to 12 over 13. Here we multiply this equation 1 by 13, and we get that X equals to 12L over 13. Likewise, the right big triangle ABC is similar to the right small triangle EGC according to angle similarity rule, and therefore the following relationship exists between the 2 similar triangles. GC over EG in the right triangle EGC equals to AC over AB in the right triangle ABC. Repeat again. GC over EG equals to AC over AB. GC is 12 minus X, GE is L, AC is 13 and AB is 5. So if we found out that according to equation 2, 12 minus x over n equals to 13 over 5. Here we cross multiply this equation 2, and finally we get that 5 times 12 minus x equals to 13L. Here we open the brackets on this side of this equation 2, and found out actually that 5 times 12 is 16, minus times 5 times minus x is minus 5x, and it is equals to 13L. Here we added 5x to this equation 2, and found out actually that 60 equals to 5x plus 13L. Here we subtracted 13L to this equation 2, and finally found out that 60 minus 13L equals to 5x. Now we can substitute x in this equation 2 by the value that we found for x in this equation 1. Okay, we found that x equals to 12L over 13. Found it to equation 1. So, found out of that according to equation 2, 60 minus 14L equals to 5x. And here, according to equation 1, x equals to 12L over 13. So we found out that 60 minus 14L equals to 5 times x, and x is 12L over 13. Here, 5 times 12L is 60L, so in total this expression equals to 60L over 13. And therefore we actually found out that according to equation 2, 60 minus 14L equals to 60L over 13. Here we multiply this equation 2 by 13, and finally found out that 13 times 60 is 780, and 13 times 14L is minus 169L, and it is equals to 60L. So here we added 169L to this equation 2, and finally found out that 780 equals to 60L plus 169L equals to 229L. Here we divided this equation 2 by 229, and finally found out that L equals to 780 over 229. 780 over 229 is 3.40611. So actually found out that L, that is the length of one side of this square DEFG, is equals to 3.40611 units. The area of this square DEFG equals to the length of one side square. Repeat again, the area of square DEFG equals to the length of one side squared. And the length of one side is L, and the length of one side square is L squared. And we just right now found out that N equals to 3.40611, therefore L squared equals to 3.40611 squared. And 3.40611 squared equals to 11.6016 square units. If we found out that the area of this square DEFG is equals to 11.6016 square units. Okay, thank you very much.